Let's begin with our very first chapter, that is matter in our surrounding. So there are 5 topics to be covered in this chapter, that are physical nature of matter, in which we are gonna give a brief intro to matter and composition of matter. Then we have its characteristics. There are 3 main characteristics: interparticle space, continuous motion, and interparticle force of attraction, along with diffusion. Then we have states of matter. There are 3 states: solid state, liquid state, gaseous state. There are 2 more states, basically plasma and BEC, that is Bose-Einstein condensate. That is deleted this year, so we'll not go towards that. Then we have interconversion of states of matter, effect of change in temperature and pressure on the state. Then we have evaporation. We'll study what exactly is evaporation, what is the difference between evaporation and boiling, factors affecting evaporation, and how does it causes cooling. So first of all, we have physical nature of matter. First, let's study what is matter. So matter is defined as any substance that has mass and volume and can be perceived by senses. That is, matter is something which has mass and occupies a space. Everything, each and everything in this universe is composed of matter. Then we have an activity to show that atom is made up of tiny particles, that is given in NCERT as well. This is the activity of potassium permanganate, that when we kept on diluting potassium permanganate with water, colors becomes lighter, but still it's visible, right? It doesn't become like fully transparent. The color is still visible even after continuous dilution. Right, so that is how we get to know that a matter is made up of very tiny particles which keep on dividing themselves, right? Then we have characteristics of particles of matter. There are 3 characteristics. First is interparticle space. So spaces between 2 adjacent particles in a matter is known as interparticle space. That is, matter has a space between them. Particles of matter has a space between them. See, this is given here. This is water. Sugar is added into it, and sugar particles, goes between the spaces. Spaces between water particles are occupied by sugar particles. This is the reason the level of water or the volume of water does not rises when we add solute to it. Then we have continuous motion. Second property, particle of matter is continuously moving. Particles of matter are in continuous motion as they have kinetic energy. They possess kinetic energy, and kinetic energy is directly proportional to the temperature. That means when temperature increases, kinetic energy increases, as well as the motion of the particles increases, and the space between the particles increases, force of attraction decreases. Then we have force of attraction, interparticle force of attraction. Particles of matter have force acting between them which keep particles together, and this force is known as interparticle force of attraction. That is, particles of matter attract each other, right? Then we have diffusion. The intermixing of particles of 2 different types of matter on their own is known as diffusion. So diffusion is basically the spontaneous intermixing of particles of matter into each other, right? And as the temperature increases, kinetic energy increases, that is, its motion increases, and since the motion increases, the diffusion also becomes faster. Then we have states of matter. So let's study about characteristics: solid state, liquid state, and gaseous state. So solids have definite shape and definite volume, whereas liquid does not have indefinite shape, but it has volume, definite volume. So you can understand it by an example. When we pour a liquid from one container to another, its volume doesn't change, right? So it has fixed volume, but it has no as such, it doesn't have any shape. Then we have gaseous state. It has neither shape nor a fixed volume. Then solids are incompressible at all. Liquid can be compressed a bit, and gas can be easily compressed. Gas is highly compressible. Then solid is rigid, whereas liquid and gases are fluids. So rigidity is the tendency of a substance to resist any change in its shape, whereas fluidity is the ability to flow. Okay. Then we have we can also distinguish them on the basis of their characteristics, that solid state have highest force of attraction, liquid has moderate, and gaseous has negligible force of attraction. Then we can differentiate it on the basis of the interparticle force of attraction, process of diffusion, and kinetic energy. Then our another topic comes into conversion of states of matter. So matter can be changed into from one state to another by 2 processes, that is change in temperature and change in pressure. So effect of change in temperature. Interconversion of states of matter can be done by either decreasing or increasing the pressure. So solid can be changed into liquid, and liquid can be changed into gas by providing heat. Gas can be changed into liquid by decreasing the temperature, and liquid can be converted into solid by decreasing the temperature. We can relate it with our daily life examples. So don't take it like it's quite difficult. It's not at all difficult. It's really very easy. If you relate it, just relate it with the real life examples. Okay, so solid is converted into liquid by melting or fusion. Liquid is converted into gas by boiling or evaporation. Now, gas can also be converted into solid without undergoing the state of liquid by deposition, and solid can be changed into gas directly by sublimation. Just we have example like naphthalene balls, right? We have camphor, which converts from solid to gas directly, right? Then gas can be converted into liquid by decreasing temperature by the process of condensation. Liquid can be freezed into solid by the process of freezing. So here is a fact: increase in temperature increases the interparticle space and kinetic energy of particle. Now, effect of change in pressure. Interconversion of states of matter can also be done by either decreasing or increasing the pressure. Increase in pressure decreases the interparticle space. So solid can be converted into liquid by decreasing temperature, liquid can be converted into gas by decreasing pressure, right? Decreasing pressure means we are increasing the interparticle space, and since gases have more interparticle space, it has least pressure, and so gas can be converted into liquid, and liquid can be converted into solid by increasing the pressure and decreasing the temperature. See, pressure and temperature are inversely proportional to each other. Okay, so let's go towards evaporation. We are not doing it in detail because this is just a recap video. Evaporation. So the process of converting a liquid into gas at any temperature below its boiling point is called evaporation. So before that, let's understand very important topics that are boiling point, melting point, latent heat of fusion, and latent heat of vaporization. See, the temperature at which a solid melts to become liquid at the atmospheric pressure is called its melting point, and the melting point of ice is 273.16 Kelvin, that is 0 degrees Celsius. Okay, and the process of melting, that is change of solid into liquid, is known as fusion. Okay, and then we have our boiling point, the temperature at which a liquid starts boiling at atmospheric pressure is called its boiling point. See, here it is given. This is quite important when, for your exam point of view, because in exams the question comes like, what is the difference between boiling and evaporation? So first of all, boiling is a bulk phenomenon. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain energy to change into the gaseous state. For example, boiling point of water is 100 degrees Celsius. See, we always take example of water, because water is the universal solvent which is available in all the three states of matter, that is solid, liquid and gas. Solid as ice, liquid as water, and gas as a steam or vapor. So its boiling point of water is 100 degrees Celsius, that is 373 degree Kelvin. See, here from here we can also learn that how can degree Celsius be changed into Kelvin. See, let me show you, just a minute. So degree Celsius, you have to take it as so Kelvin is equals to degree Celsius plus 273. Suppose we have given that boiling point of water is 100 degrees Celsius. Now how can we find it in Kelvin? So boiling point of water is 100 degree Celsius. Isme will add 273 and hence we'll get 373, because 100 plus 273 is 373 Kelvin. So here comes our answer. And so what if we have to find Celsius? Suppose see, degree Celsius is equals to 273 minus Kelvin. Okay, suppose boiling point of water is 373 Kelvin. So what we'll do is Kelvin minus 273, sorry, Kelvin minus 273 degrees. So that is 373 Kelvin minus 273, that will be 100 degree Celsius. Okay. Now we have latent heat. So what is latent heat? First let's understand what exactly is latent heat. So the hidden heat which breaks the force of attraction between the molecules is known as the latent heat. Since the heat energy is hidden in the bulk of the matter, it is called latent heat. Suppose we are heating ice continuously to change its state from solid to liquid. When we provide it heat with heat, its temperature doesn't rise until the ice melts fully. So where does this heat energy go, which we are providing to the ice continuously? If its temperature is not rising, where is the heat going? So this heat is absorbed by ice to break the force of attraction between the molecules, and which we supposed to be which we calls hidden. So latent means hidden. So latent heat is the hidden heat which breaks the force of attraction between the molecules, and this is known as the latent heat. We have latent heat of fusion. The heat energy that is required to convert 1 kg of solid into liquid at its atmospheric pressure at its melting point is known as the latent heat of fusion. We have latent heat of vaporization in the same way. The heat energy that is required to convert 1 kg of liquid into gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. Let's continue evaporation. So what is evaporation? The process of conversion of liquid into gas at any temperature below its boiling point is called evaporation. So boiling, see, evaporation is a surface phenomena. From here we have got to know the 2 points. That first point, boiling is done at 100 degrees Celsius, whereas evaporation occurs at any temperature below 100 degrees Celsius. Then second point, boiling is a bulk phenomena, whereas evaporation is a surface phenomena. Evaporation is a surface phenomenon while boiling is a bulk phenomena. Now factors affecting evaporation: temperature, humidity, wind speed and surface area. So evaporation is directly proportional to temperature, wind speed and surface area, whereas it is inversely proportional to humidity. So we know very well that evaporation increases with temperature. See, when we dry our clothes in summer season, when the temperature is high, our clothes dries faster, right? And when the wind speed is fast, the particles of water vapor will move away from the air fast, and hence there will be increase in the rate of evaporation. Then we have surface area. See, when we increase the surface area, suppose uh, mm, when we are drying the clothes, what we does is we spread the cloth to let it dry, right? So why? So that the evaporation becomes faster. And when we see, there is one more example. When we drink milk or tea in a glass, it gets cool very slowly, right? And when we put it in a pan or a saucer and then we sips, the evaporation occurs fast, and hence it causes cooling. This is because simply there is a greater surface area for the liquid particles to escape from. Then increased humidity in the atmosphere would decrease the rate of evaporation, as there would be a lot of water content already present in the air, making the air around saturated. See, humidity is the amount of moisture present in the air. So if water vapors are already present in the air, where will the evaporated vapor go? Right, there will be no space. This is the reason evaporation decreases with humidity. Now, how does evaporation causes cooling? Let's understand with an example. When we pour some acetone or nail polish remover on our palm, the particles gain energy from our palm and evaporates, which causes the palm to feel cold, right? To feel cool. We have a few important questions. Let's visit them one by one. So, what are three characteristics of particles of matter? They have interparticle space, they are in continuous motion, and they have interparticle force of attraction. Second, a gas completely occupies the vessel in which it is kept. Justify this statement. See, gases have very weak interparticle forces of attraction. They have very large interparticle space. Due to this, the particles freely move in any random direction. Hence, it completely occupies the vessel in which it is kept. Okay. Then we have what is matter. So, anything that occupies a space and has mass is called matter. Now, find which of the following are matter. See, chair, air, smell. No, not smell. Chair, air, almond, and cold drink. These four are matter, because love, smell, hate, thought does not have any mass, and it doesn't occupies any space, right? It doesn't have any volume. We can only feel it, we cannot see it. Okay, this is the reason these are not matter. See, fourth question we have is, try to break a piece of chalk, a piece of charcoal, and a piece of iron. In which of the above three substances the forces of attraction between the particles to be highest? First of all, we'll explain what is interparticle force of attraction, then we'll go towards the question. This is the way of writing answers in the exam. The strength of the force of attraction between the particles varies from one kind of matter to another. Obviously, among all the options given, a metal piece of iron does not break easily, hence it has the highest force of attraction. Now illustrate with the help of examples that particles of matter are continuously moving. The smell of food being cooked in the kitchen reaches us even from a considerable distance, right? Is it true? Yes. How? By the process of diffusion. The fragrance of burning incense stick spreads all around. This is also because of diffusion and the kinetic energy. The smell of perfume spreads due to diffusion of perfume vapors into the air. The solution of a crystal of copper sulfate or potassium permanganate into a glass of water. The solution turns blue or pink respectively. The whole solution turns into a color, right? This is also because of the continuous motion of the particles. Okay, then we have our sixth question. Give two reasons to justify that water is a liquid. You can write in two properties of water, right? At room temperature 25 degrees Celsius, which is our normal room temperature, water is a liquid because it has the following characteristics. Because it has indefinite shape and it has definite volume. It has a tendency to flow, hence it can be called a liquid. Seventh, what produces more severe burns, boiling water or steam? This is one of the most common questions that comes in exams every year. So steam produces more severe burns than boiling water. This is because steam possesses additional energy in form of latent heat of vaporization. This is the energy absorbed by boiling water during state change from liquid to gas. So when steam falls on the skin and condenses to form water, it gives out this additional energy, resulting in more severe burns when compared to boiling water. Then we have to differentiate, we have to tabulate the differences in the characteristics of states of matter. We have already discussed it. Finally, we have come to the end of chapter by the mind map. So let's visit it. So our chapter is matter in our surrounding. There are characteristics of matter, three characteristics: space, motion, attraction. Then interconversion of a state can be converted by temperature and pressure change. We have states of matter: solid, liquid, gas, plasma, BEC, and we have evaporation and boiling. We have few definitions also. Those are latent heat of vaporization, latent heat of fusion. We have our melting point, boiling point, and freezing point. So these were a few important questions from this chapter, and we have done this chapter with mind map, important questions, notes, and explanation.